Hello, my friends. This is Scott Moore, and you're watching the SMC Journal podcast, where we talk about performance engineering in IT today. And that has to do with performance testing, tuning, monitoring, observability, AI ops, observability, hardware, software, and any other kind of ware that there is. So, yeah, including firmware. I'm going to talk today about something that is very close to my heart because I learned it a long time ago. I'm going to share it with you. And this episode is going to give you something as a load tester that you can use right after this. And if some of you are fairly new to load testing with maybe a year or less of experience, this is something that I wish that somebody had given me when I first started out. Those of you who are more advanced and this is below your, standards or whatever, you're so fancy, you may not like it, but maybe somebody can get something out of this episode. Let's find out. Let's find out what RIP is in the title. I know you're wondering what RIP, realistic load testing with RIP. Yeah, I just kind of made it up, but we'll find out more about that. But I learned about RIP, which I'm going to tell you what that is in a minute, way back in 2000, I believe it was, and I used a product called LoadRunner to run a load test, and I needed it to be more realistic. I didn't need to create a test that was exactly the same every time, where the users are running at exactly the same pace, the same number of transactions. I needed randomization, but I needed it to be controlled randomization. In other words, I just didn't want everybody to go willy-nilly. I just wanted to be able to create some kind of deviation, and that's what we're going to deal with today, is deviation in your load test, but still be able to end up with the same number of virtual users, the same number of transactions, and we're going to dive in that in a minute. But that product that I used was LoadRunner, and it just so happens that the makers of LoadRunner sponsor this show. We are sponsored by Micro Focus, the makers of LoadRunner Professional, Enterprise Cloud, and Developer. They have the largest community of practitioners in the world, and if you'll scan that QR code, you'll find out more information about them. You can also go to community.microfocus.com. They also have a LoadRunner family page on performance engineering. You can find out all about these different products and different modules that they have, as well as a performance engineering video playlist on YouTube. We're also sponsored by my friends Folk Consulting. Ryan Folk and his team are highly qualified consultants. They know application performance management, testing, and monitoring. So if you're needing help and you need advanced consulting resources all around application delivery or performance or digital management, no matter what it is, contact folkconsulting.com and see what they can do for you, because I've known these guys, some of them for decades, and they have seen and done it all, and I'm sure that they can help you as well. And we want to thank our sponsors so much for sponsoring this show and the performance testing community. So now let's talk about this RIP thing that I want to introduce you to. Some of you may already know about this. I am surprised at how many have never even thought about this. So here's the situation. You've got a load test and you have 100 virtual users that you're going to ramp up to. You're going to run this test for an hour. If you can get that far to 100 virtual users, you're going to end the test after an hour, and maybe that's a abrupt ending, or maybe you want to find out how good your memory is being released, if it's being done properly, if it's being released appropriately. You ramp down a slow amount of time, and then you can find out if it's working or not. There's different reasons for different ramp up and ramp down times, but let's just say you got a 30-minute ramp up, an hour-long test, and a 30-minute ramp up. It's a 90-minute test, great. But that fixed hour of time, think of sort of like a horse race, a weird horse race, where all the horses are at the starting gate and one horse launches out before everybody else. That would be a ramp up. If you just let every horse out of the gate, that would be a true horse race, but it's not what load testing looks like when you're trying to ramp up, because you first want to see at these lower levels, 1, 2, 3 virtual users, what the timings are, because sometimes you can get to 1 or 2 virtual users in your load test and you're already way outside the boundaries of what your objective would be. You think you're going to get 3-second timings, you're getting 15-second timings. So, okay, let's stop the test and figure out why at these low levels it's not working. But let's say we actually can get up to 100 virtual users. That's 100 horses at a gate, and you're releasing the horses over a period of time, not all at once. And then How do those horses run? Do they all run in lockstep, or is there a little bit of randomization? Horses are running around, some are getting ahead of, some are taking longer to take steps than others and get behind, and others, accelerate forward. That's kind of like a load test. So there are pause times between steps when you've recorded a business process and user is navigating through various places, entering searches, logging in, logging out. And in between these steps, if we wanted to just take out all think time and let the computer run it as fast as it possibly could, that would be unrealistic, but we would call that sort of a stress test, not a load test. What a load test really tries to do is create this perfect storm, something that is peak load, something that would really happen in production, worst case, but realistic, meaning there would be a level of think time in there. Now, you could say, let's put a setting up where every single virtual user, as soon as it starts, takes 3 seconds between steps. And we put a think time either programmatically or through the runtime behavior and say 3 seconds. Well, that means that everybody is starting, stopping, pausing 3 seconds, starting. It's like, so you're going to see this wave of activity on your infrastructure that looks like that, kind of a heartbeat. Now, we take that think time and we go, let's make that a random number between 3 and 5. Maybe some users are faster than others. I mean, in real life, that would be the case, right? Some people have been through the application hundreds of times. They know exactly where to go. They click, 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 get their job done, and they move on. Other people are trying to find out where stuff is at because they've never seen this before. So you might have fast users, advanced users, and people who are new users. So if you were to create a randomized think time, now you've got people that are starting and stopping like this. So your wave, your blip, kind of evens out a little bit. But you've still kind of got this overall wave that's happening. Because let's say you've got this 60-minute window of time where these recorded business processes, even if you play them back from beginning to end, a full path, a navigation path, might take 30 seconds, might take 2 minutes, might take 5 minutes, but after it's done executing and that execution window is done, you still got a 60-minute window to fill up time. So back to our horse race analogy, horse comes out of the gate and runs around the track and stops. And what do? Well, they wait on the next user to come around and do that? No, the horse is going to keep running around the track, and eventually it runs around enough time till the race is over. And that's what you want your virtual users to do as well. Now, I know this is all basic and you know all of this, but what happens from the time that 2-minute business process is over? Now it's waiting to run again. If you don't set any kind of pacing, then it's generally, as soon as that ends, then it starts running again. Now, if you've done your proper scripting techniques, you're going to have different data being submitted. So maybe it's doing searches. The second time it searches, it just search for a different search word, but it's still doing the same business process. And if you don't set pacing, it's just running. As soon as it ends, run, 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 run. So as you ramp up, you've got this constant runtime. There may be think time between steps, but if there's no time between the time of end to a new beginning, a new iteration, we would call that, then you are probably going to have more transactions per hour in that hour-long test than probably really happens in real life. That's just my guess, unless you are doing some kind of multiplying factor on their virtual users where 1 equals 10 and you're running them more on purpose, you're trying to cheat on your license or whatever you're trying to do. But typically, you're going to do some kind of analysis on how do users act. And you're going to be asking those questions. Well, who are the users? Like, what are their credentials? Are they anonymous users? Do they have certain permissions? So can I get to all the things I need to get to? Who are users? What are they doing? Okay, what are the navigation paths for all the business processes that we want to cover in the test? And then how often are they doing that thing? So if we knew we needed to get up to 100 virtual users, we would also want to know about how many times per user a business process should be run in a 60-minute window to equal the volume that we're looking for. So this is really about volumes. So if I know that each virtual user takes, 2 to 5 minutes to run, and there's a limitation for how many times it could run in a 60-minute window, right? If something takes 5 minutes to run, you can divide 5 into 60 and find out, well, I can only run so many times. But when you've got randomization built in there and a little bit of deviation, we still need to have some level of control. We need to be able to say, all right, I want these things to run a little bit differently every time, with pausing steps a little differently for each time they run, each iteration. And then when the iteration stops, before it starts up again, each time that happens, I want a randomized number in there. So I'm going to have to start doing some calculations to say, if I get beyond a randomized window that breaches this 60-minute window, that's the big constraint there, I may run it too few times, I may run it too many times, I may attempt to run it too many times. So either my volume is going to be way off in either direction, positively or negatively. And this is where I go to my random interval pacing, RIP. That's what it's called. And let me show you this picture. This is a setting, a behavioral setting, a runtime setting in LoadRunner. I'm not sure which version this came from, but you should see something similar in whatever version you're using. There usually are 3 options, and don't worry about the fact that one of them's highlighted, but generally the 3 options are: as soon as one iteration for one virtual user ends, pick it right back up and start all over again immediately. The second option is, if that previous iteration has ended, either wait a fixed amount of time, i.e. 30 seconds, or wait a random period of time, whatever number, but between such and such a seconds, high and low, and kick off the script again. Or that third option is, don't even wait for the iteration to end, just kill the iteration and start it all up again. But we are assuming here that the iteration has actually ended before we try to start another one. We wouldn't want the load testing tool to kill that iteration. So when you think about that, this presents us with a lot of options, and not all load testing products have this capability in here. Most of the commercial ones that I know of do. But this is where we get into this idea of random interval pacing. Okay, that's what I'm talking about today, and that's what RIP is. Here's where I learned it from, and it's not some complicated mathematical formula, which you'll see, but I was doing one of my first tests at a big 5 corporation that I had been hired for. They do accounting, consulting. They've been around for about 150 years. It's not hard to find out who they would be. And I had actually just gotten hired by them, and I kind of had to prove myself. The first thing they did was threw me into a lab situation. Now, this is back in the day, so this is early 2000s, late 99 or so, early 2000. And Microsoft had a lab facility in Las Colinas, and we were testing a Microsoft product that was brand spanking new at the time. Not a lot of other companies had even rolled this out. There were only a few customers who had it. It turned out to be SharePoint. Later on, it morphed into SharePoint, but this was the early days of that. We actually got a whole bunch of people from our team and went over to Las Colinas, Dallas, Texas, into this lab for about a 7-day, no days off, 14 hours a day lab assignment, where we took the same servers that we were going to use, built out a production environment, built out the database with all of the data in it, recreated the application basically that we were going to use in production in this lab facility, and did extensive performance testing on it. People were looking at all configuration files. We had people from Microsoft. It was using SQL Server on the back. We had people who were writing the code for SQL Server, looking at what was going on in this application. And one of the Microsoft consultants that I was working with on this started talking to me about random interval pacing for my load testing. Now, I had known about the randomization as far as I knew the settings in LoadRunner that you could choose, but I didn't have a methodology around why I chose that. So when he brought up the fact we want a specific number deviation, and he said, I want a 30% deviation between runs. And you could have chose any percentage and it will still work the same way, but it basically means every time I run this test, I want there to be a high number and a low number that creates a deviation between all virtual users and how they iterate through this test, so that they pause. It's one thing to have think time between steps, but they pause how long they wait before they run again. I still want to run X number of transactions, or I want almost the same volume every test, but I want those data points to hit at different places every time. Now, there are use cases where this doesn't work. Some people need to run a load test exactly the same way every time. They need the data points to be exactly the same so they can run baseline comparisons, and that's all fine and good. This is a point where we get into the realistic part of it, a realistic load test where users are unpredictable. And what we were looking for is, we, from a database perspective, needed to find out when user threads and user sessions were stepping on each other in the database, and that meant creating some level of unpredictability, if that's a word, so that some users, first time we run the test, some users are not stepping on each other very much at all, but then in other tests they were. And this would help us find locking situations and latching situations in the database that would pop up. And so we just came up with this really simple formula. So those of you, right now, I want to preempt before I show you this, those of you who are mathematician geniuses and you want to apply calculus and everything else to all of your formulas, and you only use R for graphic, visualizations, and you got all this, and it's like, okay, I get it, and there's a need for all of that. I'm not that person. Okay? I had to have something simple and fast to get me through this test. So here's what we came up with, and I'm going to share it with you today. We would take a single business process. So this would be known as a script in LoadRunner, whatever you might call it. It's an automated business process. User logs in, does X, Y, Z, logs out, you put the timings around it, you've got a business process or a script. You load the script into, in LoadRunner's case, you load this into the controller. The controller has a runtime setting value for each business process that you run independently, or you can do group settings where you apply them all to all the groups that are running business processes. So the main thing is, let's say I only had one recorded automated script. I'm going to apply some behavioral things with this iteration pacing setting. Let's say it takes, rounding everything off, we got a 60-minute window, a 60-minute test after ramp up, and we've got a 60-second execution time. So that means every time this business process runs normally, it'll take it 1 minute to run. How many times could it possibly run in an hour? Yes, I can do that kind of math, right? 60 minutes in an hour with all things being equal. But you only want to run this script 10 times in that hour, because if every user in that 100 user list of users ran as many times as it could, 60 times, you would blow your volume out of water. It wouldn't be a realistic number. It would be more of a stress test than it would be a load test. So from the volumes, because you've talked to the business analyst, you've talked to QA, you've talked to people who know the application, that if you had 100 virtual users, that's fine. We want 100 concurrent users, but the amount of volume per that 60-minute window is only 10 times per hour per virtual user. So that way, we can really do some simple math that says we have 600 seconds of total execution time in this business process. Now that includes the think time that's in there as well. But the rest of that hour is space, meaning when that virtual user runs the business process through one time and it takes 60 seconds, it's waiting on something else to do. And if we tell it, if you run more than 10 times in an hour, you're going to run too much. You're doing over our volume of what our analysis says we should be running. So now the script is going, okay, well, you want me to run 10 times per hour, so you've got to pace me out, right? You want me to run 60 seconds, stop, and then you've got to run another 60 seconds somewhere during the test. So as the clock goes around, every so often, you're going to run for 60 seconds, run for 60 seconds, run for 60 seconds. And at the end of the test, each virtual user would have run 10 times. 10 times 100. Okay, you do the math, right? So if you don't set the pacing to a random value and you leave it as a fixed value, there will be a problem. And so here's what happens there. You have 3,600 seconds in a 1 hour time frame, right? And you know that your script runs for 600 seconds during the whole load test, 60 seconds times 10. So that means even after this script has run the execution time in an hour that it needs to run, there were 300 seconds in the rest of the hour that it has to do something, it has to pause for. So if you did some basic math and you divided that remaining, take out the execution time, you're left with 3,000 seconds. How many times did we say we wanted each virtual user to run per hour? 10. Divide 3,000 seconds by 10, you end up with a baseline number for your pacing. That is your starting point. Now here's the problem with that. If I run for 60 seconds and then I wait for 300 seconds and then run again for 60 seconds, and remember, going back to our horse race analogy, if all the horses come out, even though they've got random think time and pause time, there's a little bit of deviation in there, I'll give you that. But what you're really going to see is everybody's running, everybody's stopping, everybody's running. So you've kind of, with the random think time, between that wave, you've kind of made it kind of round instead of sharp, right? You've stopped the wall. You've kind of rounded it off, but you're still seeing a wave form, and you'll see that very easily in your test analysis where everybody's running, everybody's waiting, everybody's running. Now your CPU doesn't care, right? It just knows whether it's waiting or whether it's doing it. It wants to do work. It's ready to work, right? And it doesn't care about this, but from a volume perspective and from a constant load perspective and how we would try to mimic reality, this becomes very important. So what we've got to do is we've got to put a deviation there. So, and this is the hardest math that I'm going to share with you today. So if your baseline, as we go back and look at this, if this baseline was 300 seconds and that was a fixed time, what we'd want to do if we want a 30% deviation is we want to get a high number, 30% deviation, and a low number, 30% deviation. So it's very easy. You take that 300 baseline, multiply it times 30% or 0.3, and then you multiply it by 1.3 or 30% to the positive, and you'll get a number that's higher than 300 and a number that's lower than 300. That's your randomization upper and lower numbers that you want to stay in. If you stay within those numbers, you're probably going to run 10 times per hour. There may be a time where you kind of overstepped it. If every one of them weighted that positive 30% amount, you might run over the 10 times and the test would end anyway. So it doesn't really matter that much. So you may be off by 1 or 2 iterations, but if you stay within that upper and lower boundaries of numbers, you're still going to get the same volume while you're getting randomized think time and randomized iteration pacing, which takes that wave and just smooths it right out where you've got constant load on the system, randomizing, people stepping on each other, threads stepping on each other, database tables stepping on each other in a way that mimics real users, in my opinion. Now, could you take this even further? You absolutely could, and you could get freaky with it. This is where I'm going to stop, right? But wouldn't it be great? Just wouldn't it be great if there was somebody who had already done this calculation for you with a 30% deviation, put it into an online spreadsheet, and shared it with you who've never tried it before? I thought you might say that, and that's why I did it, right? So I have created this online spreadsheet. It's a Google Sheet, and it's called the Performance Test Scenario Builder, all right? And so at the top of this, I'm just going to walk you through the front page of the first section of it real briefly. I've already put in the numbers here. 60-minute window, which equals 3,600 seconds. We've got a 20-minute ramp up, which is 1,200 seconds, and we want to ramp up to 1,000 users. This is just an example. You can go in, you can download this spreadsheet, put in the numbers or whatever you want, and watch all the formulas change. In this particular example, I think I put something like 5 business processes or 5 user stories, and then I knew, this is just me having done this in the past, you're going to talk to the business, you're going to talk to your team, and you're going to find out, well, out of these business processes, remember, who are users, what are they doing, how often are they doing it? So I could find out, how do I distribute my users? I'm building a user profile for my load test. So the number of users per business process, and I know from the timestamps or the transaction timings that I'm putting in the script, using LoadRunner as an example, I'm putting a LR transaction time in the script. I count how many times there are, a start and end transaction. So every stopwatch timing, I would call that. That's how many transactions are in that script. So then I can start doing some math on them. I also know how much think time I might have hard coded in there. Let's say it was 5 seconds per step. I'm just throwing that out there. But then in LoadRunner, you can say, I don't care what you hard coded, change that to a random value between blah, 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 or multiply that think time between a random value upper and lower. So this think time right here that you're seeing in this column is a fixed number. We will turn that into a random number later, but that's what I had hard coded for the whole script. And that's all based on, if you've got a credit card that you're credit card processing application and you're filling out some long form, or a realtor type form that you're filling out online, and it takes you 3 minutes to answer that form because it's a lot of information, it's all detailed. You would put way more think time in that than you would, search, enter, like a Google search or something, right? But then you also will come up with, out of the number of times I need to run that per test for all of those virtual users, once you kind of get that, then the rest of the information is sort of filled in for you in this yellow. You'll see it when you go on the thing and download it. But it does the calculations for you, and it includes a 30% deviation, a high number and a high number and a low number that I can put in LoadRunner that then matches what you see in this screen here. And so you could use that last one like I'm showing right here, random, an interval between low number and high number. So again, if our 300 seconds became 270 seconds or 240 seconds and 450 seconds, whatever that was, if you still stay within that randomization time, you're still going to have the same number of iterations as if you had that fixed time. But it's a much more realistic way of pulling off that load test. Now, what I'd like to see is someone take this to the next level. Download a copy of that spreadsheet, play with the formulas, look at all the things that are there, and there's even some validation and checkpoints that kind of looks at, okay, you've got this number of users, this amount of volume, you're trying to run your users and you're trying to pace them in too little amount of time. It'll actually highlight in red, it'll tell you shouldn't do that. So that's a different podcast I could to walk you through that, but it's pretty self-explanatory when you go through the spreadsheet. But it would be great if you took this, went through it, applied it to a project, applied it to a load test you want to do, and maybe come up with a way to make it better. Maybe there's some additional math that needs to be considered as well. There's actually a second sheet. Maybe I'll just extend that to the next podcast and go into that sheet, and we'll talk about the other, where we take values out of a load test from the test results that using these behavioral settings, and then posting those in for, this is what it ran when it ran really aggressively, this was a different deviation, and just start looking at the numbers as a whole from the test results that come out. Then we can find out, are we running the users too hot still? Are we not running them hard enough? Then we can kind of make those decisions and adjust our behavioral settings, whether that's randomized think time or randomized interval pacing, and make it better. But I want to know what you think. It would also be great if somebody said, you know what, I'm really good at taking something like this and turning it into an application. You can go to this form and fill it out and hit enter, and it spits it all out for you, and maybe even create a LoadRunner scenario file, .lrs or something with settings in it. That would be kind of cool. I just never have had the time to do that. So maybe you'll do that. What do you think? Am I full of it? I will tell you this, okay? If I'm full of it, my whole career is based on a sham, because I have done this for almost every load test that I've run. I have had to adjust and tweak a few of the numbers here and there, but for the most part, I hit it very close to the volumes that we expected when I have all the information available to me using this spreadsheet to guide me. I've been able to run countless number of load tests, get really good results, really close results to what we saw in production. I've never had anybody come back and challenge all these numbers and say, this was all wrong, you were totally off, and here's why, and get out the chalkboard and become Einstein. Never had anybody do that. However, now I'm on the internet on YouTube, so I'm waiting for you. I know you're out there. But great, I'm wide open. If I'm wrong, show me. Let me know where I have, but I have never run into a situation where this has worked against me. It may not have been completely 100% accurate all the time. And for tests that need to run the same way every time, this is not the use case for that. Love to hear what you have to say. I'm easy to find on the internet. Contact me at scottmoore.consulting, through LinkedIn, through Twitter, or email me directly at help@scottmoore.consulting. Also, it would be great if you do like this content, or if you just want to fight, sign up for the YouTube channel and click the bell, and you'll see when we release content, which usually is every Tuesday and Thursday at 8 a.m. Eastern Time in the US. So that is how to create realistic load test, or more realistic load test when you need to, with random interval pacing, or RIP. For this episode of the SMC Journal Podcast, this is Scott Moore saying thank you for watching, and we'll see you next time. Bye-bye.